So this guy is a very important piece, and it's basically the entire hub of the X-axis. So I already built it here, just drilled and countersunk some holes. These 4 holes are for the actual linear bearing. These 2 holes here are for the acme nut, and I still need to drill holes and build a harness for holding the plasma cutter head. So let's install this guy and see where the acme thread lines up and start getting the motor on. So the brass nut for the X-axis is going to be in a slightly different orientation than the Y-axis. And it's going to sit right here and get installed right there. And the thread is going to run just like this. Install everything loose first and then tighten later. Now start TIG welding the extra brace here. All I'm going to do is just put a couple tacks down. So as you can see here, I have a couple of options for outfitting this bearing. I can put something like that, and I can just slice it off, and then I have my rigidity there. This is a relatively thick piece, so I might be in good shape. I can do something like this and cut this guy up. That might actually work too. I'm going to take one of these guys and mount it either straight up, which would need to put a bend in there, or I can go at some angle. So for the first bearing, I decided to go with the C-channel here. I think that it was already pre-cut at this angle from a previous project that I did, so having it sit exactly where I wanted to, angle was good. It gives me 2 degrees of rigidity. So I think I'm just going to cut this guy up like this, and I think I'm going to be in good shape here. Perfect. The coupler exists in order to transmit power, rotational power, from one entity to another. It makes up for any types of misalignment or torque by twisting a little bit to give, it's kind of like a clutch with springs on it. What I decided to use, and there's tons of different types of couplers you can get on eBay or any other type of website that has CNC type stuff. I'm using fuel hose and a vacuum hose that's basically going to go right inside, push it right in there. And the reason I'm doing that, it's only for half the length. The reason I'm doing that is to make up for the differences in diameter between the 1/2 inch acme thread and the output of the shaft of the motor. This end goes into the acme thread, and this end here goes right to the shaft, the output shaft of the motor. It fits in pretty nice and snug. And then I use what's called an Oetiker clamp, O-E-T-I-K-E-R. So this is essentially an Oetiker clamp kit. Comes with a whole bunch of different size clamps. Usually they're specified in millimeters. So this is basically what you do. You use special pliers, and they're two-way pliers. Basically crimp the end like this. You can do it that way, or if you're in a tight spot, you can use the other end, clamp them that way. So the idea is that you clamp it like this, and as you're clamping, you're compressing it to its minimum thickness, which, as you can see, when it gets down to it, is smaller than the outside diameter of the fuel hose. So that's the idea here, and that, yes, these are one-time use clamps. As you can see, the only way to remove it is to destroy it. But they really do clamp tight. They clamp uniformly around the entire circumference, so it's a really good clamp if you never want any leaking from some high-pressure fuel hose. So that's why they're good for fuel hoses. This is going to be spinning a lot too, so I didn't want to use a worm-type gear assembly that's going to have a big rotating mass on the outside, because these motors are going to spin pretty quickly. Okay, so this guy goes in there, the other end goes there, and it's rubbery enough to allow for any type of misalignment or transfer of torque to make it a little bit easier on the system. So this is a temporary mock-up. This is not going to be the final installation, but I'm going to take the whole thing apart later. Might as well thread it on. I'm going to take the whole thing apart anyway to paint it. But for now, this is good. Alright, so I got it sitting in place here. I got it to the right height, just like on the y-axis. The x-axis acme thread needs to be at the right height throughout the entire side. This is being supported in 2 dimensions. I know it's just tacked on for now, but down here it's tacked, and it's also tacked up here, preventing it from moving back and forth. It might end up moving a little bit on the back side because it's not supported here, but I'm going to end up putting a piece of aluminum here that kind of braces it. So now I'm ready to drill the hole in the right location.